there's a little bit of information I skipped over, didn't even remember was there. And it has to do with this concept now. So it's under T cells. You find the section on T cells, and then we're looking for, and I think it's bold, class 2 MHCs are found only on blah, blah, blah. And then below that, class 1 MHCs are found on membrane surface of blah, blah, blah. So as far as the outline, it's Roman numeral 5, third line of defense. After specificity, diversity, self-tolerance, immunological memory, then we go on to talk about T cells, 4 major types. And then just after that, class 2 MHCs are found, class 1 MHCs are found. Got it? Mm-hmm. All right, so class 1, MHCs found on membrane surface of most nucleated body cells. Infected or abnormal body cells present endogenous antigens to CD8 T cells via class 1 MHCs. So to go along with that, right here, and this is the only difference between what I'm showing you today and yesterday, instead of dendritic cell, what I had right here was abnormal or infected body cell. And then the rest of this was the same. And then over here, we had CD4. And I went on to describe how CD4 T cells are activated. And then we ended up with our effector cells at the bottom, which included helper T. And then I had a dotted line going over here showing that the helper Ts had to secrete cytokines that activated the CD8s. So this is CD8. MHC1, how CD8 T cells get activated. Well, the way I showed it, it implied that the abnormal body cell simply displayed antigen to CD8, and that resulted in activation, provided cytokines were coming over from helper T. But that didn't make sense because, well, where's the helper T? Where's the cytokines coming from? You can't activate a CD8 T cell with an abnormal body cell. You have to use a dendritic cell. Now, once you activate your CD8 and you form your cytotoxic T cells, then your cytotoxic T cells, they can go and target the abnormal body cells. Right? And they will interact with the class 1 MHC, and they'll identify it as an abnormal body cell based on the antigen it's presenting, and they'll go ahead and attack it. Okay, but that's once you have your cytotoxic T cells. Well, how do you get them? You got to get them first, right? So your dendritic cell, and we had an image of this. I can put it up. So the dendritic cell is using its class 2 to communicate with the helper. So we've already gone through, we've activated CD4, we've made our helper Ts. The helper T is confirming that the antigen being presented by this dendritic cell is in fact something that we've identified and need to get rid of. At the same time, the dendritic cell is presenting antigen to the CD8, which has yet to be activated. That's the whole point of this. So the cytokines are released from the helper. Helper says, yes, I've seen this. This is what activated me. So we do need to destroy this. Releases the cytokines and allows the CD8 to become cytotoxic T cells, which can now go around and find these abnormal body cells and destroy them. The question becomes, how does a dendritic cell end up with endogenous antigen inside of it? Right? Because the dendritic cell must have somehow gotten a hold of this endogenous antigen, processed it, and displayed it on its membrane using its class 1 MHC. Well, the answer was right there in the study guide. I just skipped over it. So after it says infected or abnormal body cells present endogenous antigens to CD8 T cells via class 1 MHCs, it says note, we now know that APCs, dendritic cells specifically, also use class 1 MHCs, allowing them to activate CD8 T cells. How? The dendritic cell uses phagocytosis or gap junctions to take the endogenous antigens that are in the abnormal body cell and internalize them and then present them on the surface. So before we can activate a CD8, the dendritic cell has to get a hold of this endogenous antigen. Why is it called endogenous? Because it's appearing within these abnormal body cells. It's not something that was ever out in the ECF. Right? It appeared in this abnormal cell either because of mutations to this cell's DNA, that's why it's making abnormal proteins, or it's just a body cell that was infected, let's say by a virus. And now we're making viral proteins inside this body cell. So the dendritic cell internalizes these endogenous antigens one of two ways, literally engulfing the entire infected cell, and thereby engulfing the endogenous antigen at the same time, or forming gap junctions with the abnormal cell and taking up the endogenous antigens that way. So now you've got a dendritic cell that has a hold of endogenous antigens from an abnormal body cell. It's now displaying them in its type class 1 MHC. Now I didn't want to show all the details as far as how the helper is binding, so I just made one little arrow and just a little note. Helper T also binds to this dendritic cell at the same time. But if you want to see what it looks like, it's right here. Here's the helper using its CD4 protein to join up with the class 2 MHC, using its T cell receptor to join up with the antigen. And then here you have your CD8 using its CD8 cluster differentiating proteins to bind to the MHC, class 1, and then its T cell receptor to bind to the antigen. So that's how you activate CD8s. So if you go back to the beginning, you have an abnormal body cell that shows up for whatever reason, mutation or infection. What's the first thing you need to activate to start dealing with this antigen? CD4 or CD8? At this point, we have no helper, we have no cytotoxic, because there's been no interaction with this antigen, right? This is showing up for the very first time in some abnormal cell. So this abnormal cell starts to display this abnormal protein in its membrane using class 1 MHC. So who gets activated first, CD8 or CD4? Because you can't activate a CD8 without helper T. Well, you don't get helper T until you activate CD4. So it starts with CD4. How do you activate the CD4? So the dendritic cell would have to internalize this endogenous antigen by engulfing the abnormal cell or creating gap junctions with it. And then that dendritic cell can come along and interact with the CD4. Right here. So this dendritic cell has the antigen that it took from the abnormal body cell, either through gap junctions or phagocytosis, presenting it to a CD4 for the first time. Well, you don't need help from helper T to activate a CD4, right? Because this is how you get your helper T in the first place. There's no sort of checks and balances. There's no double checking here. We don't need it. When we make CD4, or when we make helper Ts from our CD4s, they're not going to go out and destroy anything. We don't have to worry about that. What we're worried about is making the cytotoxic. That's when we do double checking. Okay, so we've activated our CD4. Get your clones. Some of them become helper. Okay, now you have a helper that can be used to activate CD8. Right, so the same dendritic cell or a different dendritic cell, which has the endogenous antigen, right, through phagocytosis or gap junctions, is displaying it in both its class 1 and class 2 MHC. And the class 1 is being used to interact with the CD8. But that's not enough to activate it, right? You need chemical stimulation from the helper. So the helper is also interacting with that same dendritic cell at the same time, using the class 2. So now you have not only your helper Ts, which we mapped out on the left, and that was all correct, you also now have your cytotoxic Ts. And the map we did on the right was all correct as well, with one exception. Take away what I put here originally, abnormal body cell, replace it with dendritic cell. Cross out abnormal infected body cell, replace it with dendritic. And maybe make a little note off to the side as to how this dendritic cell got a hold of an endogenous antigen. Now, how would a dendritic cell get a hold of an exogenous antigen? Just run into it in the ECF. Exogenous, it's out there. And that's really the main job of dendritic cells. They're all over the body. They're in all of our tissues. They're even in the epidermis. They're in our mucous membrane, and they're looking for antigens. And they find them, and they internalize them, and they break them into pieces, and they display the pieces for the immune system. So it starts with activating CD4. You get your helper Ts. Now you can activate CD8. Now you have your cytotoxic Ts. And then what else can you use the CD4s, or the helper Ts for? What else can you activate now that you have helper Ts? B cells, exactly. Now, would a B cell be useful for an endogenous antigen? No. Right? Because B cells make antibodies, and antibodies can only interact with antigen that's in the ECF. This is also why you always need both. You need cytotoxic T cells for cell-mediated immunity, and you need your B cells for humoral immunity. Right? And then it depends on where the antigen is. If it's in the ECF, if it's outside of our cells, antibodies can interact with it. But if it's inside of our cells, antibodies can't do anything. So now we have to rely on cytotoxic T cells to detect the abnormal cell and destroy it.
But it was saying that antibodies can attach to some viruses and slip into the cell with them, and if they get into the cell, then it was talking about that in the book, that it's not common that it'll slip in the cell, and it can do internal cellular work, it's just not as effective.
Oh, okay.
So once it's like, if it's attached onto the virus, when the virus goes into the cell, then it can do stuff, but it won't go into the cells searching out the virus.
Right. And it sounds like when it goes in with it, it may hinder the virus a little bit, but the virus can still...
Once it gets inside there, it starts to try and mess up its...
Yeah. But you're not ultimately removing the virus. You would still need cell-mediated immunity to actually destroy the cell that contains the virus. Yeah. We good? Break.